Okay, welcome everyone. I'm Alex Helfand, responsible for the Salty Dog webinar series. Tonight, I'm really happy to be able to have invited Chris Parker from his weather routing services to come join us. I recognize a lot of folks who are on here tonight who have been down with us in the Caribbean. I'm actually talking to you from Annapolis, but I'll be back next week. And tonight's webinar is one that I hope you all find interesting. For us being in the Caribbean the first time this year, we were very surprised at how windy it was. I think some of the old timers were too. Anyway, it just seemed to me that we had a winter that maybe is not normal. Whatever normal is. So I thought I asked Chris if he could talk to us about what we've experienced and then talk a little bit about what we might anticipate coming our way, particularly for those who have to, who want to go home with their boats this spring. So with that, I will turn it over to Chris and remind everybody to please put your questions in the chat box and we will get to all of them at the very end. And with that, Chris, it's over to you.
All right. Thank you very much, Alex. So let's see. Can I resize that box or is that static? That looks like it's static. Okay.
Yeah, presentation. Show me the
Okay. So as Alex mentioned, we're going to talk about a couple of topics this evening. One is the sort of weather we've seen this winter, maybe one of the reasons for it, the ENSO cycle, El Nino, La Nina cycle, and we'll give you a little outlook on what may happen for the rest of the winter season and the sort of weather patterns we'll be looking for on the way home. And we won't get a whole lot into that. We'll do another webinar on that as a departure is approaching. So it's been kind of windy in the Caribbean this winter. If we look back at the last couple of years, this is a history of the El Nino La Nina cycle over the last couple of decades. And the areas in blue shading are relatively cool sea surface temperatures in the central South Pacific, basically French Polynesia area and French Polynesia over toward Tonga and Fiji. And it's a little bit north of that, so it's really the southern part of the tropical Pacific. So that has, we think, one of the biggest bearings on hemispheric weather in the Atlantic Basin and in the Pacific Basin, as well as in some other places. It's one large factor in seasonal trends. So these are degrees Celsius on the scale on the left. You can see that a really strong La Nina would be a cooling of sea surface temperatures in this box between French Polynesia and Tonga and Fiji of up to 2 degrees centigrade Celsius. And we've seen a relatively modest La Nina, but it's continued for about 3 years. We're in the 3rd year of it. Some of La Nina events are shorter in duration. There was a really long La Nina from late 98 into 2002. So that one lasted 3.5, almost 4 years. And this one back here in the mid 80s also lasted about 3 years. So it's certainly not unprecedented to have multi-year La Nina events. The El Ninos, that would be warmer sea surface temperatures in the central South tropical Pacific, are often a little higher in magnitude between, so the strong ones are maybe between 2 and 3 degrees Celsius, but they tend to be a little bit shorter in duration. And the last La Nina we had was late 2018 into 2020. So what sort of weather do we have in these sorts of seasons? This is a look at the continental US and, well, really North America weather patterns based on La Nina and El Nino. This happens to be El Nino. And in an El Nino, we tend to get a bifurcated or bisected jet stream with the polar jet stream sinking southward, lots of warm air in the west and central US, and it tends to be quite moist in the southern latitudes. The reason for that is the southern branch of the jet stream. So normally, or in the weather pattern that we've got this year, it's been a much more unified jet stream. So all the upper level energy is focused in one single jet stream, and it's fairly far north. And the jet stream brings cold fronts, squally weather, cooler weather, a lot of moisture. And that's all been up north this winter, and it's been particularly bad out west, where, and I'll show you what happens in a La Nina in a minute, but the western US has been getting exactly the opposite of warm and dry this winter. It's been cool and wet. Meanwhile, we've been very warm and dry here in the eastern US. I believe the first significant snowfall event we had of the whole winter season in New England was last week. And it's been largely a winter without snow and with relatively warm temperatures. And in Florida, it's been quite balmy. I don't think we had a hard freeze here in Central Florida. And we typically get 1 or 2 hard freezes a year. And we had 1 or 2 freezes that were predicted, and we got down to just barely 32 degrees, and then it warmed right back up. So I think that's kind of unfortunate. We got a lot of weeds in the yard. And when we have hard freezes, the weeds die and the grass grows back. Well, this year, it never got cold enough to kill the weeds. So the weeds are winning over the grass. So it was a warm winter. And I think winter's pretty much done. I don't think we're going to get a whole lot of cold air heading into the deep south and Florida going forward. So in an El Nino year, we have the opposite. There's a lot of moisture in the southern branch of the jet stream, and the jet stream is split into 2 parts. Between the 2 parts, it tends to be warmer and more dry, but there's a lot of moisture and a lot of cooler air along the southern branch of the jet stream, very active across Mexico, Texas, Gulf of Mexico, Florida, southeast US coast, and the southwest North Atlantic, including the Bahamas. So the folks in the Bahamas complain in El Nino winters, as is pictured here, that there are a lot of really strong cold fronts. There's a lot of west wind. It's really wet. It's really squally. It's really cold. It's really miserable. I love the Bahamas, and whatever it is in Florida, it's better in the Bahamas. But it can get really cool over there, and it can get a little bit frustrating when we've got day after day after day of west winds and strong cold fronts. So in the Caribbean, we don't typically see a lot of effects from an El Nino year. The cold fronts may be a little bit more numerous getting down into the Caribbean, particularly the Western Caribbean, but still it's very hard for them to penetrate into the East Caribbean. But what we do see is relatively lower surface pressures in the subtropics, and that tends to reduce our trade winds in the Caribbean. So El Nino years tend to have lighter trade winds in the Caribbean overall. That's the most significant effect. This is what we had this year. This is a La Nina, and out in the Pacific, that's how it looks, but we're going to focus more on North America. And notice the unified jet stream. So the jet stream is all in one piece. There's no big jet stream down in the southern, in the subtropics. And we tend to get much drier and warmer air in the southern tier of the US, Gulf of Mexico, Florida, Bahamas. And we tend to get wetter and colder conditions in most of the northern tier of the US, with the exception of New England, which is sometimes warmer and cooler. Warmer and more moist or drier. And so it just varies. The effects of a La Nina on New England varies depending on where the jet stream sets up. The jet stream this winter has been kind of unusually far north. So much of the eastern US has gotten in on the warmer, drier weather. And the cooler, wetter weather has been kind of from the Great Lakes and upstate New York westward, and not really along the eastern seaboard. So what does this mean for the Caribbean? Well, what it means for the Caribbean is, notice in this figure, we don't have a lot of big waves of energy in the atmosphere that are really hemispheric in scale in terms of the jet stream. Compare that to this, where we've got one big unified wave of energy curving northward, then eastward, then southeastward in the Western Pacific. So this tends to set up a really persistent area of high pressure, a blocking high, south of Alaska in the northeastern Pacific. And that induces, just like a wave in the ocean, there are waves in the atmosphere. So if you get flat water in the ocean, then everything's fine. But if you get a wave where the water level increases in one place, the water level doesn't just stay the same the other place. It actually, the wave actually, the wave water upwelling actually induces a water downwelling. So the positive wave induces a negative wave. So because we've got this blocking high pressure out here, it induces more of a trough across some part of the US that's more unified. And as that comes northward, it induces a blocking high pressure ridge in the Atlantic. So the same thing that we have here in the Pacific, we typically have in the Northwest Atlantic, Greenland, Iceland, the North Central, and the Northwest Atlantic. It is that is the culprit in our trade winds. Big high pressure up north and a lack of cold fronts between the Caribbean and the high pressure. That is a recipe for strong trade winds in the Caribbean, and that's what we saw this year. Of course, the trade winds are driven by differences in pressure over distance, the pressure gradient. And when we have big high pressure to the north, we always have lower pressures toward the equator. That causes a tightening of the wind gradient, more difference between high pressure and low pressure, and that causes more wind very directly. And that's what we saw this year. When a cold front gets in between, you got the high pressure area up here. In this picture, there's my cursor. There's the area of high pressure. And notice where the Caribbean is relative to the area of high pressure. We're getting, in this image, strong easterlies at around 20 knots in the East Caribbean. If we put a cold front between that area of high pressure right there and the Caribbean, if I stuck a cold front in here, we would find the wind in the Caribbean gets chopped significantly. It's much, much lighter because most of the pressure gradient is between the cold front and the ridge of high pressure. And it's not on the other side of the cold front. So the fact that we've had big high pressure to the north and a lack of cold fronts to the south has resulted in strong trade winds in the Caribbean. That pattern has broken down over the last couple of weeks, and we have seen a marked change in our weather. And I guess just be a good time to comment on that. What we normally see in winter in the East Caribbean is a lot of variability of conditions. We'll get some days or weeks where we've got pretty consistent east-northeasterly to easterly trade winds. They tend to be somewhat north of east in most of the winter. And, 15 to 20 knots gusting 20 to 25, seas 5 to 7. So, around 6 feet, kind of brisk sailing, especially if you're on a small light boat. But not anything that most of us would consider really inclement. That's what we have a lot of times during the winter, and it's just beautiful. Well, when we have, and even during a typical winter, we will get days, maybe even a week or 2 or 3, where we get really persistent, strong trade winds and big seas. Winds that are, I like to think of 20 knots as kind of the break point. If we are under 20 sustained throughout 24-hour periods of time, then we don't get a lot of sea surface evaporation, or at least nothing above normal. We don't get the seas picking up a lot in height. And those conditions are pretty reasonable for most of us. And even if we throw in a couple of squalls, maybe it gets occasionally up into the mid or upper 20s in some gusts, but if it's only periodic, that's not bad. But now let's look at wind that is, nominally in the low 20s. Now the sustained wind is going to be 20 to 25, but it's going to be gusting 30. That's going to lead to more evaporation from the sea surface, more low-level moisture pooling, more showers and squalls. So it'll pick up 30 to 35 in squalls, and we'll have more coverage of those squalls. So instead of being, 10 minutes every night in most areas, it's maybe an hour or 2 or 3 of off and on somewhat persistent squalls. And that's going to have more of an effect on the seas. So if we just increase the baseline wind 5 knots from, say, 17 or 18 knots to 22 or 23 knots, we probably increase the average seas, the mean sea height from, I'm talking wind-driven seas, from about 6 feet to about 8 or 9 feet. And, because we're going to have wind 20 to 25, gusting to 25 to 30, and squalls to 35. And that's gale force wind, 35 knot gusts and squalls. So that really piles the seas up. And, even if we get some moderation late this afternoon, this evening, the seas are still going to be up tomorrow. We have to wait an additional day for the seas to settle down, and then maybe we've got more wind by then. So if we have short windows, they don't do a whole lot for us when it's really super windy, because it takes time for the seas to abate. So normally we get some of each of those, good weather and bad weather, in the winter in the East Caribbean. What we've had this year is much more persistent windy weather. So from about kind of the middle of December through about the middle to latter part of February, there were some days where we got some breaks, but probably 80% of the days, or something like 2/3 or 3/4 of the days, were the windy variety. And we had relatively few periods of mild settled weather for about 2.5 months in the middle of the winter. That's a little unusual, but it's typical of a La Nina year. So what do we have now? Remember last week, I guess they did the super yacht racing in Antigua, and there was almost no wind, and that was the last 10 days. I think it ended about a week ago. So it was kind of early March, and we often see the subtropical ridge of high pressure settle southward into the waters just north of the Caribbean in late spring. Typically, it's sometime in April or May. We'll have periods in the East Caribbean where it's good trawler weather. There's just no wind, and there are mild seas, and it's beautiful weather, and it's not really squally yet. The tropical waves haven't started coming in yet. And it's gorgeous weather, especially if you're a trawler, but oftentimes there's not a whole lot of wind for sailing. It's unusual to find, there were about 2 weeks, right at the tail end of February and the first week or 2 of March, or first week of March. There were about 2 weeks or so there where most of the days really didn't have a lot of wind along the northern part of the basin. That's very typical, but it's more typical of April or May than it is of early March. So that was a little weird. Going forward, I'm not sure we're going to get a repeat of that. And I'll show you that in a second here. just discuss for a minute the importance of the location of the ridge of high pressure. So it's a little tough to see, but I'll describe it. This is an area of high pressure. The orange lines around it are isobars. And, oh, Alex, you asked, have we had more swells from the north than expected? No, I actually, oftentimes, I think we had less swell from the north than usually happens. And the reason for that is the swell from the north is caused by north wind on the backside of low pressure systems. And those low pressure systems that would propagate big seas down toward the Caribbean would track from the US East Coast or southeastern Canada eastward into the Northwest Atlantic. And then the north wind on the backsides of the areas of low pressure is what causes the strong seas, the north swell, to propagate into the Caribbean. But with high pressure anchored in the Northwest Atlantic, and it wasn't there, every day, but it is as soon as a cold front in an area of low pressure came through, then the default was to snap the high back in place right away. So we still got cold fronts coming off the coast, but instead of having just a slow progression of the next weather feature coming in, the high just snapped right back in place. And so that caused shorter durations, I think, and less north swell and stronger easterly trade winds. A lot of times in El Nino years, we actually get more north swell. I think the surfers got some good weather this year, but we didn't have a lot of days where the swells were, 10 feet plus out of the north in the Northeast Caribbean. And in a La Nina winter, we would have a fair number of those days where the swells would be 10 feet plus out of the north. And that really wasn't the case this year. So the importance of this area of high pressure, there's no wind inside the middle of the area of high pressure. To the south of it, there's an easterly wind. To the southwest of it, there's a southeasterly wind. To the west of it, there's a southerly wind. And as we get up on the northwest and north sides of the area of high pressure, it's more of a southwest to west-southwest wind. So typically in the Caribbean, we're south of the area of high pressure and we get the easterly trade winds. That's why we get them. And when this high is centered a little further west, then we're on the southeast side of it where the wind is somewhat east-northeast. And that's our default position for the winter. We typically get east-northeasterly trades in the winter. In the late spring, early summer, this area of high pressure typically migrates southeastward. We get onto the southwest side of it and we get east-southeasterly trade winds. And that's a real bummer for folks who, let's say, spend the season down in Trinidad or Grenada. They look to go north in maybe December. Well, by December, we've got east-northeasterly trade winds. So it's upwind going north. And then they wait until, May or June to go south. By then, we've got east-southeasterly trade winds, and it's upwind to get south. So that's a thing. On the way to the U.S. coast, we are going to transition through the ridge of high pressure, and that's pretty important. So the sort of weather we can expect on the way home is we will leave the tropics with east-northeast, and by that time of the year, maybe easterly trade winds in early May. And then there's a clockwise flow of air around the subtropical ridge of high pressure, and we tend to get really, really light wind. So we split the trip up into 3 sections. The first section is the remnants of the easterly trade winds. We're going to leave the Caribbean. The wind's going to be out of roughly the east, probably 15 to 20 knots. Let's hope. We get into day 3 and 4 of the trip. The wind is going to be veering more to the southeast and getting lighter. So we'll be on a broader reach, more of a downwind run maybe, and the wind will be getting lighter. So one thing we can do is try to find a way to not be on such a deep sailing angle when the winds are getting lighter. And that could require more of a motion to the west toward the Bahamas, or more of a motion to the north toward the offshore waters. But when you go north, you're going to encroach into the ridge really quickly and lose your wind really quickly. So usually the way to maintain the best wind leaving the Caribbean for the longest time is to basically head for the Bahamas, because there you stay south of the ridge at least longer than you would if you headed more to the north and in better wind for sailing. But eventually you're going to have to go across the ridge where there's going to be very little wind. Sometimes there's a south to north flow of wind through the ridge. So typically we transit the western part of the ridge, not right through the center, but there's going to be some sort of a south wind as we go through the ridge. Now, if there's not much of a weather system to the north pulling air through the ridge, then there's not much of a south wind through the ridge. So maybe it's 5 knots, and that's not really useful. But if there's enough of a weather system to the north that it pulls air across the ridge, then we can get sailing conditions with wind out of the south at 15 knots or whatever, what have you, sailing across the ridge of high pressure. So that's zone 2. Zone 2 is going through the ridge of high pressure. The wind either gets really light or probably veers to the south, or some combination of those two. And it's all good settled weather, and there's no big weather related problems. Zone 3 is where we have the troubles. And zone 3 is in the upper latitudes north of the subtropical ridge of high pressure. And this is where we have migratory low pressure systems passing, and strong cold fronts, and really squally, messy weather, and gales and storm force wind and thunderstorms. And so in my opinion, what we want to do is we want to break the trip up into 3 parts in our minds. We want to spend as long in part 1 as possible, all else being equal, which is south of the ridge in east or southeast winds for sailing. We want to cross the ridge of high pressure in a relatively perpendicular fashion where the winds are really, really light, because we don't want to motor extensively along the axis of the ridge. We want to get through the ridge fairly quickly. So once we decide we want to penetrate through the ridge, we're going to turn more to the north. We're going to shoot through the ridge relatively in a perpendicular fashion. But we also want to minimize our time in zone 3, north of the ridge. That's where the weather gets really dicey, and we get strong cold fronts, gale force winds, storm force winds, thunderstorms. And, the weather pattern that we have when we're approaching departure is going to dictate the exact routing. But, sometimes we get intervals of time when we have maybe 4 or 5 days of good weather north of the ridge, and you can emerge from the ridge at maybe 30 or 32 north at around maybe 70 or 72 or 74 west, out in here. And, in 4 days, a relatively fast boat could be in New England, and you get there before the next significant weather event. More often, we've got about, if we time it just right, we've got a maximum of about 48 hours from the time that we get north of the ridge to the time that we want to be in port along the US East Coast to avoid heavy weather. Now, that can vary. It can be a lot shorter than that. It can be longer than 48 hours. But typically, if we time it right, we hopefully can get 48 hours of good weather to get to the coast. So most boats, if you're at around, 30 or 32 north at 72 west, when you come out of the ridge, you couldn't be in the Chesapeake Bay in 2 days. So depending on what the weather pattern's like, it may not be practical to go straight to the Chesapeake or New England unless you're a super fast boat, or unless we get a really good weather pattern. The more conservative thing to do is to spend more time in the tropics and the subtropics south of the ridge, come up and parallel the Bahamas, staying just northeast of the Bahamas as long as we can stay in the wind for sailing. And then as the wind gets light, make a turn north across the ridge and time that all so that when we get north of the ridge, we've got good weather and we don't have a cold front coming like a freight train ready to wipe us out. So we have to time that northward turn really carefully, but we got a lot of time to do it. We're, kind of paralleling the Bahamas in a west-northwest or northwesterly fashion. We can even extend further west and north of the Abacos, turn towards central Florida. So we can extend out. If you're a pilot, we can do, a long downwind run, and we can choose when we're going to turn to base and final, depending on how things are evolving in the weather. So we've got a lot of residual runway to use to time our northward turn when we're not going to get clobbered. So that's the strategy that I kind of like using for heading north. So what sort of weather do we have coming up? This is the El Nino La Nina forecast. Getting back to that topic, we are currently in a neutral pattern. We were in a fairly strong La Nina earlier in the winter, but just in the last month or two, we've gone to neutral, and we're no longer in a significant La Nina. What we are likely to have this coming winter season is, and these are the months, so this is June, July, and August. By June, July, and August, we've got about a 50-50 chance that we'll be in an El Nino. And after the June, July, August 3-month period, when we get into the 3 months from July, August to September, there's a better than 50-50 chance we'll be in an El Nino. So next winter is very likely to be an El Nino, and it's likely to start somewhere around the middle to latter part of the summer. So hopefully next year in the Caribbean, we've got less in the way of trade winds. I'm sure there will still be a lot of days with strong trade winds, but overall, a little less in the way of trade winds and easterly seas. Unfortunately, that probably will mean maybe a little bit more northerly swell. In the Bahamas, by the way, well, I mentioned the El Nino effects in the Bahamas. I didn't mention the La Nina effects in the Bahamas. In the Bahamas, the La Nina effects are the same as in the Caribbean. Really persistent easterly trade winds, northeast and east. A lot of wind, big seas, but relatively fewer and relatively weaker cold fronts and relatively less wet and squally. And that's certainly what we've seen in the Bahamas this year. So I guess the only other thing that I have prepared is a little bit of a seasonal outlook. And I think I'm going to stop that sharing and share something different. So I'm going to share the whole browser window, and I want that browser. Okay. Did I lose the chat box? I hate it when it does that. Yep. Okay, there we go. And I'll get to the questions here in a minute. So find the right tab here. This is the weeklies, and this is the dailies. And I couldn't do this before because the 12 Zulu run hadn't finished yet, but it's finished now. That's the European. We want to look at that, and the, I guess, GFS ensemble. Okay. So over the next few weeks, here's what we can expect to see in the Caribbean, just from a kind of an overall weather situation. Right now, we've got relatively strong easterly trade winds being driven by relatively big area of high pressure to the north. Here, the scale is, this is an anomaly forecast. So normal is in white. A positive anomaly that would be higher upper level heights, or you can think of it as areas of higher pressure, would be in yellows, oranges, reds. A negative anomaly, areas of relatively lower 500 millbar heights, you can think of that as areas of lower pressure. We have the blues, the purples, the greens. And so what we see now is there's a big anomalous area of higher heights, I think higher pressures, over much of continental Europe, extending through the Azores and the Canaries, all the way across the Atlantic. I mean, this is just massive. It's all the way from Nova Scotia to the north part of the East Caribbean. It extends through the eastern half of the US, Gulf of Mexico, West Caribbean, in massive anomalous area of upper level high pressure. Because this is relatively close to us, it's not causing the trade winds to be massively high. It's just relatively fresh trade winds in the East Caribbean. If this area of high pressure were further north, we would have a lot more wind down in the Caribbean. This is the European ensemble on the left, the GFS ensemble on the right. And as we go forward, we see there are some breaks in the upper level ridging, but simultaneously with getting a break in the upper level ridging, when a trough digs in, we get an amplifying of upper level high pressure or higher heights adjacent to it. So that's going to help to maintain the trade winds, maybe back the direction a little bit, eventually to more of a northeast direction. But overall, you know, we've still got, with the exception of a couple little breaks, nominally a big ridge of high pressure in the continental Europe and Northern Africa and the Mediterranean. And the same thing in the West Central Atlantic, the Western Atlantic, Southeast US coast, Gulf of Mexico, etc. Does seem that we're going to have some troughs digging into the Central Atlantic, but that doesn't completely get rid of the subtropical ridge. Notice there's some slight anomalous ridging, even northeast of the Caribbean, where the trough is trying to dig down. So all the way through here, we're getting weaker signals as we get further out, because an ensemble forecast tends to gravitate towards the mean. So we should be seeing fewer and fewer deviations from neutral as we get out toward the end of the forecast period. And certainly we're seeing that. So this is a relatively significant signal. I mean, it doesn't look very significant, but to have a consistent subtropical ridge that is still forecast to be from continental Europe and the Med and Northern Africa across the entire Atlantic, down through the Bahamas, Gulf of Mexico to Texas. The models agree on that on the 3rd and 4th of April. You know, that's a pretty significant signal. So I would imagine that the same sort of weather that we've got going on now, moderate to relatively strong trade winds, but nothing like we saw in the winter, but just modestly strong trade winds, that's probably going to continue. Now, if we get some really strong cold fronts to the north, that can shove the ridge of high pressure southward into the Caribbean, and that's what gives us our really light winds. So for instance, here we've got a big upper level trough coming off of New England on Wednesday, the 29th. So that's going to drive the ridge southward toward the Caribbean. If it drives it far enough south, we'll get some really light wind in the Caribbean. We're probably going to see that off and on, maybe a couple of days a week. We'll get relatively lighter trade winds in the Caribbean because of that. I want to show you one more slide. This is the same thing, the 500 millibar anomaly, European model on the right, GFS, European model on the left, GFS on the right. But these are the weeklies. So this is a longer term, and this goes out to, I think, early May. It's got lower forecasting skill. It's not much better than being blindfolded and throwing a dart at a dartboard, but it's very slightly better than being blindfolded and throwing a dart at a dartboard. And it shows, you know, kind of the same thing, even extending through, you know, this is Tuesday, the 4th of March. So this is essentially what we're looking at the on the other pair of model representations. And, you know, we're seeing the same thing, big ridge of high pressure, subtropics, and we've got areas of lower heights in the upper latitudes north of that. And as we go through the balance of April, it does look like we'll get some, maybe a little bit more decaying of the big continuous ridge, and we'll get some sort of a significant separation that occurs in the West Atlantic. So this is an interesting feature here on the GFS model. That's a big ridge of high pressure that is discrete. It's not, spread out from Europe to the US. It's really discrete in a small area. There's a big ridge of high pressure in the north central and northeast Atlantic. And that's helping to induce this troughing in the southwest Atlantic. Now, the European model doesn't really have that, but the European model looks much more neutral. But we could easily see as we get into mid-April, some breaking down of the subtropical ridge that might result in some lighter winds in the East Caribbean. We might also get a more aggressive cold front every now and then that probably doesn't dig down into the Caribbean, but may cause some nasty weather a little further south of 30 north in the subtropics, east of the Bahamas in mid-April. So now we've got the high pressure as we get into latter April. This is 18th, 19th, 20th of April. Notice now the upper level ridging tends to be at a much more northerly latitude. Northern Europe, going across the North Atlantic to the Canadian Maritimes and over the US. And between that and us, we've got this area of maybe a lower height anomaly. It's not very strong. It's not a strong signal, and we don't have complete agreement between the two models. But we're definitely seeing the ridging lift further north. That could provide us with stronger trade winds if that ridging is strong enough and it's not blocked by an area of low pressure between us and the ridging. So as we go through the latter part of April, we might get a rebuilding of trade winds. We'll probably also get more unsettled and squally weather in the Western Atlantic between us and the Eastern US because of this tendency for troughing. And this is a look into very early May, and it's kind of that same pattern. It's more ridging across the northerly latitudes from Northern Europe to the Canadian Maritimes, across Canada, and periodically in the US, continental US. But if there's an anomaly from the Caribbean, between the Caribbean and the US East Coast and Bermuda, if there's an anomaly, it's a lower height anomaly, which would tend to suggest more unsettled weather. So hopefully that's a little bit of a help. And, that's just kind of a really, really, again, it's only a little bit better than being blindfolded and throwing a dart at a dartboard. But hopefully it's a little better than that. So any questions? What determines when we'll have an El Nino versus La Nina year? So it's the temperatures, sea surface temperatures in the 3.4 geographic area. So, and so 3.4 map. So this is a good image. Yeah, this is a really good image. So, blow that up. So it's the sea surface temperatures in I said it was the southern tropical central Pacific, didn't I? Well, it's actually equatorial. It's actually the equatorial. So this is region 3, and that's in the eastern tropical Pacific. This is zone 4 in the western tropical Pacific, and zone 3.4 is in the central tropical Pacific. And it's basically between 120 and 155 west. Is that one? No, that's 170 west. So between 120 and 170 west. So that's basically north of the waters between the Galapagos and the Marquesas, to north of around Fiji, Tonga area, north of Tonga. And when those waters are warmer, that's an El Nino. And when those waters are cooler, it's a La Nina.
So Chris, the next question was, what's the effect for heading east above 36 north?
So if you're heading to the US East Coast, based on what we're looking at in the forecast, I would guess it's going to be a pretty typical late spring, early May. We're just at the very end of the weekly forecast series that we just looked at, which extended only into to very early May. And we saw that maybe there's a little bit of an anomalous tendency for more unsettled weather than we would normally get. Slightly more and slightly stronger cold fronts might affect the West Atlantic waters in general in late April, early May. Whether that continues beyond that, I don't know. And it's only a slight tendency. So where we would normally get maybe, let's say, 10 cold fronts in 6 weeks between late April and May, maybe we'll get, instead of seeing 10 cold fronts, maybe we'll get 11 cold fronts or 12 cold fronts. So it's a slight increase in the frequency. And instead of the average cold front having wind to 30 knots, maybe the average cold front will have wind to 32 or 33 knots. So it's slightly stronger and slightly more frequency, but it's slight. So it's not like it's the difference between having cold fronts and not having cold fronts. We're still going to get them. It's just that there may be relatively more of them and they may be relatively stronger. So again, what I would do if you're looking to head up to New England, we'll have to assess what the weather situation is and what the probability is that you're going to get to New England without being clobbered by something you don't want to get clobbered by. Sometimes it's a really easy decision. Sometimes we can look at it and say, there is no way that you're going to get there without seeing conditions that you don't want to be out. But we may also have, I don't expect this, but we may also be able to give you a green light and say that we don't see any problems, that, maybe there'll be a little bit of squally inclement weather and a weak cold front, but there's no big risk for any really nasty weather. We may be able to give you the green light. Not likely, but it's possible. More than likely, what we're going to have to say when we're looking 7 to 10 days out, depending on your boat speed, and a couple of days before, we're doing this discussion a couple of days before departure, so we're going to be looking out 9, 10, 11, 12 days into the future and trying to guess what's going to happen and factoring in what might happen. So more than likely what we'll say is that you want to minimize the amount of time you spend north of the ridge of high pressure, which is around maybe 26 or 27 or 28 or 30 north. And once you're north of the ridge, you're on borrowed time. A front will eventually get you. The question is when. And do you have time to get to port somewhere before it does? And how strong will it be when it does? So I would say that it's unlikely that you'll have a good forecast for leaving the Caribbean and heading straight to New England. It's possible. But what we're probably going to have to do is say, until you get up to latitude 30 or 32 north, you're going to kind of favor a course that's a little closer to Bermuda and use that as a bailout. Or maybe until you're up to a similar latitude, you're going to favor a course toward the Bahamas, kind of heading toward Hatteras, so that whatever happens, you've got a lot of bailout options. You can bail out to the west into the Bahamas. You can bail out to the west-northwest into Florida or Georgia, or more to the northwest into the Carolinas, or you can go around Hatteras and bail out into the Chesapeake Bay. So to your starboard, there's really only one bailout other than heaving to, is Bermuda. To your port, there are a lot of bailouts that I mentioned. So we'll have to decide when we see the weather situation, whether it looks like you're more likely to want to bail out to starboard or to port, and make the decision on routing, which side of the course do you favor based on which way you're likely to want to bail out if that becomes necessary. Does that make sense? What's the strategy for going to the East Coast through Bermuda? So it can actually be pretty tough to get from the US East Coast to Bermuda. So what often happens there is we get on the south side. Oh, and I'm not sharing the right thing. We get on the south side of the ridge of high pressure, and we get, we get on the north side of the ridge of high pressure, and we get west winds. So portion of the screen. So imagine that Bermuda is up here based on this, or right now it's right there in this forecast. And this is from a couple of years ago. But let's say that Bermuda was up here. Well, you've got wind between Bermuda and the Chesapeake Bay that is southwest or west-southwest. And it may be too close to reach for sailing, and it may be too strong. So you might be 30, 40, 50 degrees off the wind, where you're really beating the boat to heck trying to go to windward. And it may be in wind that's 20, 25, 30 knots, and it may be squally at times. So that can be really tough. It tends to be easier to go to New England because you've got better wind angles. But especially early in the season, you also tend to get more and stronger cold fronts and more risk for really bad weather, and not enough time to get to New England without being hit by at least one front. So it's easy. It's one other option is to consider a point between the two. So maybe you sail, instead of being locked into going to Norfolk and sailing a course that requires motor sailing to hold anything close to a course for Norfolk for a while, maybe you decide to stay as far south as you can while sailing and not having to motor sail or tack for it, and not getting so far north like you were going to Newport, and you end up heading for the Delaware Bay. So that's another option, is you do sort of a compromise, sail as close to reach as you can. If you can't lay the Chesapeake, then you lay Delaware Bay.
Okay, there was another question. What's the strategy? This is actually, I guess, for next year, is see, from the Chesapeake to the Bahamas in November.
So Chesapeake to the Bahamas in November. So it's essentially the same thing in reverse. We want to get through the zone that's north of the ridge of high pressure as quickly as possible. And if you want to make a lot of easting to the Caribbean, you may want to linger in the middle zone, zone 2, where you're along the ridge of high pressure, so you can make your easting. And then if you're headed to the East Caribbean, you typically want to delay getting into zone 1, south of the ridge, where you're going to get your easterly trades. Because once you're in that area, you're just going south basically toward the Caribbean in easterly trade winds. Heading toward the Bahamas, you can typically do more of a straight shot. But usually what we see in the Bahamas is we are south of the ridge of high pressure. We get north winds behind a cold front, and then imagine as this area of high pressure slides east relative to our position. So I'm going to move my cursor around the area of high pressure instead of moving the area of high pressure, but it has the same effect. So behind the cold front, we get north wind initially, and then we get northeast wind. On the third day after the cold front comes through, we've got east wind. That's good for sailing south to the Bahamas. On day 4, now we've got southeast wind, and that's not so good. It's putting us on a closer reach for the Bahamas. And on day 5, when we're still not quite yet in the Bahamas, we got south wind, and we really want to be going south or south-southwest. So the risk for going to the Bahamas is that before you get there, you end up with southerly headwinds, and those can be pretty strong ahead of a cold front. So especially if you're a slower boat and the weather cycles are fairly short, then there may not be time to get from the Chesapeake Bay to the Bahamas without running through the whole weather cycle, where you get a strong cold front followed by north wind behind it, wind veering northeast, east, southeast, south, and eventually southwest out of the next front. That would be an entire weather cycle. If you don't have time to get to the Bahamas before that cycle finishes and you get the south wind at the start of the next cycle, then you're going to end up with headwinds for part of the trip. The solution for that is often to leave from Beaufort. And if the windows still aren't long enough to leave from Beaufort, then you just keep heading down the coast to Southport, to Charleston. Eventually, you will need less and less time to get to the Bahamas. Instead of needing maybe 6 or 7 days to get from the Chesapeake Bay, if you're an average speedboat, you may need 4 to 5 days from Beaufort. You may need 4 days from Southport. You may only need 2.5 to 3 days from Charleston, and you may only need 48 hours from South Georgia, North Florida. So eventually you're close enough to the Bahamas that your need for a weather window is short enough that you're rewarded with a window that works for you. So that would be the solution to not having long enough windows to get to the Bahamas.
Okay, now the next question is actually just the reverse. For going from the Bahamas to Chesapeake this May, I think you touched on it a little bit, but maybe if you could.
So again, you want to so from the Bahamas to the Chesapeake, we have a little more confidence in the weather forecast on your departure, because now we're really only looking out, depending on your boat speed. You can use the Gulf Stream heading north, so you move a little quicker. A lot of times you can leave the Abacos and be in the Chesapeake by the end of the 4th day. And if you're a really fast boat, you can do it even faster than that. So we really only need a 4-day weather window from your departure, or maybe 5 days if you're a little slower. And we're only, we're talking about that 1 or 2 or 3 days ahead of time. So now we're within the 5 to 7 day time frame when we're trying to make decisions before departure. And we can have a lot more confidence in what the weather's doing versus when we leave the Caribbean, we're in the 9 to 12 day time frame trying to figure out what the weather's going to do. So that's a benefit of leaving from the Bahamas versus the Caribbean. You're not going to spend a whole lot of time south of the ridge in zone 1 because you're really close to the ridge. Sometimes the ridge is right over you and you're in zone 2 on departure. So you may or may not spend any time in zone 1 south of the ridge. But once you get through the ridge and into that 3rd zone where we get the migratory cold fronts and low pressure systems, then you do want to be focusing very much on getting into port before the onset of bad weather, which is going to happen. It's just a matter of when. So the solution for leaving the Bahamas is we can time your departure better so that you're not in a situation where you're going to face unexpected bad weather, because we're going to be able to expect it.
Okay. Could you review your definition of slow boats versus fast boats?
So the
How do you-
typical cruising boat today is probably able to maintain consistently on a 24-hour basis offshore in reasonable conditions about 170 miles a day, 160 to 170 miles a day. So just about a 7-knot boat speed. 7 knots would be 168 miles a day. Your average 45-foot, 50-foot monohull or multi-hull, cruising multi-hull is generally able to maintain close to 160 or 170 miles a day, near or just slightly below 7 knots on a 24-hour basis. So that's kind of what we assume for the default. A slow boat would be 6 knots, 140 miles a day, 144 miles a day would be 6 knots. So that we would consider a slow boat. We have some clients who are only doing 5 knots, 120 miles a day. That's a really slow boat. And there are a lot of weather challenges that are presented by having a boat that's that slow. We have to plan much more carefully and much further in advance in order to keep you out of bad weather, especially, a lot of smaller, slower boats don't have the motoring range either. So they don't have the option of being able to motor for extended periods of time to position themselves to stay out of bad weather. So it's a much, much bigger challenge to work with a really slow boat with really limited motoring capabilities. On the other hand, a fast boat would be 180 plus miles a day. We do have some boats that can take off reliably 7.5 to 8 knots, which would be up in that 180, 190, 200 mile a day range. Anything above 180, 190 miles a day, you're probably in a racing sled or a really, really fast, racing sort of a multi-hull. That's not a typical cruising boat. But we work with a lot of clients who do go, 10, 12 knots, 200 to 240 miles a day. But again, the default we're looking at is about 160 to 170 miles a day, 7 knots. And a fast boat would be about closer to 8 knots, and a slower boat would be closer to 6 knots.
Okay. We were talking earlier, do you want to comment just a little bit about the Sargasso? I know we don't have a lot
Yeah,
of.
so there is Sargasso out there, obviously, and I was looking before we went. Where was I looking at that? I had it pulled up somewhere. Well, in any event, oh, here it is. There is website from the USF College of Marine Science, and they've got real-time images, and this image kind of looks like it's the best one. And it actually shows the color of the sea surface. And the color of the sea surface seems to have, excuse me, some correlation to the Sargasso. So there seems to be a pretty significant concentration in the Caribbean between the Venezuela offline islands and the south coast of Hispaniola of Haiti, of the DR rather, and a fair bit toward the Windward Leeward chain. So that's one thing, and the link for that is there. Goodness.
Gesundheit.
Thank you.
Springtime in Florida.
Yes, indeed. So that link, Optics Marine USF EDU Projects SAWS HTML, that link will take you to a place where you can look at the real time and the recent history of Sargasso in the region, not just in the Caribbean, but in the Atlantic waters north of the Caribbean and along the US East Coast as well. So that's one forecasting resource.
Chris, you were saying to me earlier that the last couple of years we've been seeing an increase in this stuff, and it's not as if it's the first year that it's really nasty.
Right. There has been, and I found when I was looking online at the Sargasso analysis and forecast, I did find, well, this shows it some. Over time, the yearly trend. So I know this is really low resolution, but you can see in February 2011, there was almost no Sargasso. February 2012, there was just a wee bit well east of the Caribbean. February 2013, nothing. February 24th, nothing. February 2015, that was pretty bad. But 2016, there wasn't much. 2017, there wasn't much. 2018 was horrible. Lots of Sargasso. And every year since then, we've had a lot more Sargasso than in previous years. So 2019 was bad. February 2020 wasn't so bad. February 21, 22, and 23. 23 is particularly bad. So why there's variability to the Sargasso, just like there is variability to so many parameters and things in weather and in the rest of life. But there does seem to be a trend over time toward more Sargasso. That doesn't mean that it's going to be every place every time, but there seems to be an overall trend for more Sargasso. A couple of reasons that the scientific community is thinking there might be more Sargasso over time in general is the warming of sea surface temperatures and potentially more organic matter, more fertilizers, more effluent from the Amazon. There's been a lot of deforestation in the Amazon, and there's more nutrient-rich water coming out of the Amazon, and a lot of it. So another thought is that although if you measured it, it would be minute once it dilutes over the ocean, the amount of the increase in concentration in nutrients is very small. You know, that may be playing some part in the increase in Sargasso over time. So, you know, warming temperatures and potentially a little bit more nutrients in the water could both be contributing factors. There's probably a lot else going on. And that's, you know, certainly not an exhaustive list of what might be causing the increase in Sargasso that we seem to be seeing over time.
Okay. Then there's one last question here. Oh, there was a question if we could post the link. I'm afraid to go try to grab it myself because I know where it is, but then I might lose the whole webinar. So
Sure.
we'll try to get it afterwards. But
Yep.
with the next question was, would the Sargasso impact sailing from the Chesapeake to the Bahamas or from the basically for any of us going north? Thanks, Chris.
Yep. So I haven't done an analysis of that, and I will try to do that before we set sail. So I don't know if there will be you know, any significant effects of Sargasso on the way to the US.
Okay, that's great. Okay, any other last questions? Well, once again, I'd really like to thank Chris for his time and insight into what we've been experiencing this year and what we still have coming. I suspect our northbound trip is going to be very interesting. There will be, for those of you who are in the rally going north, the dates for and times for those webinars on routing will be posted shortly. And with that, thank you again. And a reminder, we have another webinar next week. I think it's on the 30th on sea anchors and drogues. And everybody have a great evening and stay warm or cold, depending on where you are. And thanks again.